Hello, and welcome to MedEvidence Articles, where we encourage community research and education with weekly articles. I'm your host, Benton Loeyball, and this week we're talking about how the flu virus mutates to evade our immune system. Why do some vaccines protect you for decades, while others don't? Most Americans receive the measles vaccine as children and remain protected for life. Compare this with the flu, also called influenza, where it is recommended we get a shot every year. The difference is due to something called antigenic variability, which is the ability for different parts of the virus to change over time, making it harder for the immune system to recognize newer strains. In this article, we'll look at the big differences between the highly variable flu virus and relatively stable ones like measles, and find out why vaccine effectiveness over time is so hit or miss. The flu is an incredibly common illness. In 2025 alone, around 51 million Americans were sick with the flu, leading to hundreds of thousands of hospitalizations and tens of thousands of deaths. This is in spite of many people getting the 2024 vaccine, which was less effective against 2025's strains. The problem is that the influenza virus mutates in a specific way over time, allowing it to break through our defenses. Antigens are anything in the body that triggers an immune response. This is how our body detects invaders and how the immune system latches onto and destroys dangerous particles. These antigens are on the outside of a virus and typically include proteins that help the virus attack a cell. When these antigens change over time, the virus has high antigenic variability. The influenza virus has very high antigenic variability, meaning it changes antigens rapidly over time, and the immune system has a hard time recognizing a new strain. Compare this with the measles virus, which has very low antigenic variability, and it becomes clear why a single measles vaccine can last a lifetime. The immune system sees the measles antigen once and can recognize them forever. So, how does a virus like the measles vaccine manage to survive with such low antigenic variability? The key is that antigenic variability comes at the cost of reduced infection rates. Think of viruses as, computer viruses. A computer hacker could try one of two brute force ways of accessing personal accounts: trying tons of passwords on a few accounts, or trying one password for every username they could think of. The flu is more like trying lots and lots of passwords on a few accounts. Unless you use a secure password and you change it frequently, the hacker will probably get in, but each attack takes time and the process is relatively slow. The measles is more like trying one password, 123456, on millions of accounts at once. Anyone who has changed their passwords at any point will be immune, but new users are at very high risk. The trade-off in viral disease is very similar. Viruses with high antigenic variability, like the flu, spread widely and can escape from the immune system. They mutate the proteins on their surface very easily, which makes them hard for the immune system to detect, but also means they aren't as effective at reproducing. In fact, the average person will only infect 1 to 2 other people with the flu, but its ability to evade the immune system and escape means epidemics are common. Measles represents the other side of the trade-off. It is extremely efficient at spreading, 6 to 18 times as effective as the flu, but this comes at the cost of extremely stable antigens that are defeated by a single vaccine. In fact, measles is so stable that we've been using the same vaccine since the 1960s, and it's still effective. The same cannot be said of the flu vaccine, which needs to be updated and administered every year to keep up with the evolving strains. Updating the flu vaccine is a tricky process because scientists have to predict which influenza mutations will escape each year. Scientists have to look at surveillance data of what strains of influenza are mutating, and then guess which will break out in the next 6 to 8 months. It's a difficult and expensive task. New technologies like mRNA flu vaccines are making this process faster and will help cut the lag time between detection and vaccine production. So if you'd like to play a part in moving medicine forward, consider joining a flu vaccine clinical trial, or at least go get your annual flu shot. And maybe change your passwords. Thanks for joining us on this week's episode of MedEvidence Articles. If you'd like to know more, all of our sources are linked in the podcast description. You can also visit our website at medevidence.com and Check out the Med Evidence podcast for discussions between physicians and subject matter experts. Med Evidence provides evidence-based information that empowers individuals to make informed health decisions. The organization stands apart in the presentation of unbiased clinical research in clear, accessible formats guided by medical experts. Med Evidence provides education for patients and healthcare professionals with a focus on research as a care option. Note that information provided in this podcast is for general educational, scientific, and informational purposes only and is not intended as and should not be treated as medical or other professional advice for any particular individual or individuals. If you are experiencing any medical issue or have any medical concerns, you should consult with a doctor or other medical professional. My name is Benton, and we'll catch you next week.